Chains are one of the most deceptively simple yet critically important pieces of hardware in the industrial world, holding up bridges, towing ships, lifting steel beams, anchoring oil rigs, securing mining equipment, and supporting structures where failure is simply not an option. A chain has no luxury of weakness. Every single link must survive extreme loads, high impact forces, corrosion, friction, weather, and years of continuous stress. And today on The How Factory, we're going inside the steel mills and forging plants where industrial chains are born, where red-hot metal is shaped, welded, heat-treated, calibrated, and tested with forces powerful enough to snap steel if anything is even slightly out of tolerance. What looks like a simple string of metal rings actually undergoes a long, complex, and precision-engineered journey before it's trusted to lift thousands of tons or secure machinery in some of the harshest environments on Earth. The process begins with raw steel. Chain manufacturers typically use alloy steels enriched with carbon, manganese, chromium, nickel, or molybdenum, depending on the grade and the intended load capacity. These alloys must deliver a delicate balance: toughness to resist impact, ductility to avoid brittle fractures, and hardness to withstand wear. Steel arrives in long coils or bars that are first straightened, cleaned, and cut into precise lengths. These pieces will become individual links, and the accuracy of this early step determines the strength of every link that follows. Even a few millimeters of variation affects the link geometry and can compromise load distribution. Once cut, the steel rods are fed into massive furnaces, long tunnel-like machines that heat the metal to glowing orange temperatures between 900 and 1,100 degrees Celsius. These furnaces maintain extremely stable heat zones so that every rod emerging is uniformly heated and plastic enough to be shaped without cracking. From here, forging begins. Heated rods enter automated bending machines equipped with rollers, hammers, and shaping dies. These machines form each rod into an oval shape with open ends, the initial form of a chain link. While the metal is still soft, the open ends are positioned against each other, ready for welding. But before they're closed, something crucial happens. Each half-made link is inserted through the previous link in the chain. This interlocking is done using automated manipulators, ensuring the chain forms continuously. Once linked, the open ends of each link face each other inside a welding station. These stations typically use flash butt welding, a process where a powerful electric current arcs between the two ends, melting the steel faces before a hydraulic press forces them together. The molten edges fuse into a single, seamless joint. When done correctly, the weld becomes as strong or stronger than the rest of the link. Sensors monitor current, temperature, pressure, and weld time to ensure every link receives identical treatment. A weak weld could cause catastrophic failure under heavy load, so the welding process is controlled with incredible precision. After welding, the newly closed link is not yet ready for service. Welding leaves structural stresses and slightly uneven geometries, so chain manufacturers perform a process known as calibrating. The chain passes through a machine that pulls each link into its final shape using controlled stretching forces. This not only ensures uniform dimensions, but also stress tests the weld while the steel is still malleable. If the weld has any imperfection, it will fail here under controlled conditions, rather than in the field. Successful links continue down the line toward heat treatment, one of the most important stages in the entire manufacturing process. Heat treatment determines the chain's final mechanical properties. Depending on the grade, chains undergo quenching and tempering. First, the chains are heated inside massive furnaces to precise temperatures, often over 900 degrees Celsius, until the steel's microstructure transforms. Then the glowing chain is rapidly cooled in oil or water, a process called quenching, which hardens the steel significantly. However, quenched steel alone is too brittle for industrial use, so the chain undergoes tempering. It's reheated to a lower temperature to return toughness and ductility while maintaining high strength. The goal is to create steel capable of resisting both sudden impacts and constant heavy loads. Each batch's temperature profiles are monitored continuously by automated sensors. Even a 10-degree deviation can weaken the chain or create internal stresses. Once heat treatment is complete, the chain passes through specialized shot blasting machines. These machines fire thousands of tiny steel beads at high velocity against the chain surface. Shot blasting removes scale, smooths rough spots, and improves fatigue resistance by introducing beneficial compressive stress on the surface of each link. After blasting, the chain looks clean and uniform, but the process is far from over. Now begins critical dimensional inspection. Automated calipers, laser scanners, and roller gauges measure link thickness, inside length, outside width, pitch uniformity, and weld alignment. Industrial chains must match precise measurements so they can interact with sprockets, hoists, and lifting equipment without binding or slipping. When dimensions are approved, the chain enters the proof loading stage, a dramatic demonstration of strength and a crucial quality requirement. Massive hydraulic testing machines apply forces far beyond the chain's normal working load, stretching every link under controlled tension. The chain does not reach breaking point, but it must withstand a predetermined force without permanent deformation. For heavy lifting chains, these forces can exceed hundreds of kilonewtons. Proof loading confirms that the welding, heat treatment, and forging have all produced a chain capable of handling extreme loads in harsh environments. If any link fails, stretches too much, cracks, or shows surface defects, the entire section of chain is rejected. Next, depending on the chain type, finishing processes begin. Many industrial chains receive surface treatment such as galvanizing, electroplating, or powder coating. Galvanization coats the steel in a layer of zinc to prevent rust, especially for marine and outdoor applications. Some chains receive black oxide coatings for corrosion resistance and reduced glare. Others are painted with high visibility colors used for safety in construction or mining environments. The coating process occurs in large dipping tanks or automated spray booths. After coating, the chains move into drying ovens or curing chambers to ensure the finish bonds properly to the steel. Meanwhile, high-performance chains used in offshore drilling, heavy construction, or industrial lifting undergo additional inspections. Magnetic particle testing, ultrasonic scanning, and X-ray inspection check for invisible cracks inside the metal, defects that could cause sudden failure. These non-destructive tests detect microscopic flaws in the weld zone, forged areas, or heat-treated surfaces. Only chains that pass these examinations earn certification for extreme duty applications. While the chain body is being processed, other components, such as end fittings, hooks, shackles, and connectors, are forged and manufactured in parallel. Many chains must integrate with complex lifting assemblies, and these accessories must match the chain's strength and load rating. These components are made from alloy steel, forged under massive presses, machined to precise tolerances, heat-treated and proof-tested just like the chain links themselves. Once complete, they are assembled onto the chain using special master links or couplers engineered to distribute load evenly across the chain system. After finishing, the chain undergoes final inspection. Workers and automated scanners examine welds for uniformity, surface coatings for full coverage, link alignment for proper movement, and marking stamps for accuracy. Industrial chains must display permanent embossing, often including grade, manufacturer, batch number, and size, so safety inspectors can identify them in the field. Once the chain passes inspection, it is cut into specified lengths using hydraulic cutters. These cutters slice through high-strength steel links with enormous force. Chains are then packaged into coils, drums, or bundles depending on weight and size. Heavy lifting chains may be shipped in steel containers or crates, while smaller chains are packaged in coils wrapped in rust-preventive materials. Before leaving the factory, each batch receives a certificate that documents heat treatment curves, proof test values, dimensional results, and compliance with international standards. These records ensure traceability so that any chain used in offshore rigs, cranes, or industrial plants can be traced back to its production run. The final stage is shipping and distribution. Chains destined for construction sites, factories, oil platforms, or maritime industries are sent to distributors worldwide. Many chains support machinery that handles thousands of tons, and their reliability determines the safety of structures, workers, equipment, and the environment. A single failed link can cause catastrophic accidents, which is why the entire manufacturing process, from alloy composition to proof testing, is built around safety, consistency, and extreme strength. When a chain is installed on a crane lifting steel beams or securing a ship anchor or supporting tension lines on an offshore platform, every link must perform flawlessly. What makes industrial chain manufacturing so remarkable is how ancient forging techniques and modern automation combine to produce something deceptively simple yet engineered to perfection. Behind every chain is a world of fire, heat, pressure, metallurgy, robotics, and microscopic quality control. Every link carries the legacy of centuries of ironworking refined by digital monitoring and high-precision manufacturing. And that is exactly how industrial chains are forged, welded, heat-treated, calibrated, proof-loaded, inspected, coated, and prepared for the extreme loads they must withstand every day. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machinery and systems behind everyday technology.